Now we are going to see the modern trends in a DC transmission system. Nowadays, there is a vast development in a semiconductor device and adaptive control systems, digital electronics, and DC protecting device. All these reasons increasing the use of the DC transmission. Now we are going to see one by one. Power semiconductor valves. Initially, we have used the valve as a mercury arc rectifier, which is very costly and size also very higher. Nowadays, there is a development in a power semiconductor device. The SCR was developed. Due to the development of the SCR, the reliability of the overall converter will be increases and cost also will be decreases and size of the converter also will be decreases. The voltage rating of the SCR is improved as well as current rating also improved, which increases the loading capacity of a station with a low cost and compact. Next, there is a development in SCR, that is the light triggering SCR. Because of the light we can trigger the SCR so that the cost of the converter will be decreases and reliability of the system also will be increases. Due to the development of zinc oxide gapless arresters, the cost of the converter will be decreases, and also there is some development in a protecting firing method devices. The cost of the converter will be further decreases and size also will be decreases. Next, the G2 gate turn off thyristor. It is also developed which can carry the high amount of the voltage and current, that is 2500 volts and 2000 amperes, but it requires a high amount of the gate current. The disadvantage we can overcome by developing the metal oxide semiconductor SCR or MCT, which is carrying the same amount of current and support the same amount of voltage, but it requires the very less amount of gate current. The amount of silicon required to manufacture any device that we can reduce, so the cost will be reducing if we use the CZ method instead of conventional FZ method. So the overall cost of the device as well as converter will be decreases, and also size also will be decreases due to the advancement in a semiconductors as well as a valves. Converter control. Nowadays, microcomputer based converter control equipments are developed. Due to this, we can control the converter which can able to transfer a power between the two stations during the fault condition also. No need to remove the control system. We can go for the preventive maintenance by the standby system when the converter is in operation. The mini simulators are developed which are used to check the vital control and protection of the system. DC breakers. There is a development in a DC breakers nowadays. Because of this one, you can tap the power from the DC link so that you can develop the multi-terminal DC link. Suppose if you want to operate the two converters in a parallel means, again you have to go for the DC breakers rather than operation in a series of the converters. The parallel operation of the converter is more reliable and also flexible for the planned growth of power system. The DC breaker rating is not more than the fault current during the fault. The control and protection of the empty DC system is not a direct extension of the two-terminal DC link. The control and protection of the empty DC system is somewhat different from the two-terminal DC system. Nowadays, the research is going on the communication of the signal for getting the coordinate controls of different stations at the same place. Conversion of existing AC system. Suppose if we have a AC system, now we want to convert that AC system to the DC system. So why we are going to convert that AC system to DC system means we want to improve the transmitted power. On the same route of way, if you are using for the DC means it is creating the electromagnetic induction problems. Operation with a weak AC system. What is meant by weak AC system means the system strength is defined by means of a short circuit ratio. The short circuit ratio is defined as the short circuit current level at a converter bus divided by the rated DC power. This is nothing but a short circuit ratio. If the short circuit ratio is less than the 3 means it is a weak system. If it is more than the 3 means it is a good system. Suppose if the short circuit ratio is less than the 3, then if short circuit ratio is less than 3 means if any problem is occurs at a inverter side means the conventional constant extension angle control method is not satisfactory. The recovery of the inverter from the AC fault is very problematic. So we have to go for the constant reactive current control or AC voltage control has been suggested to recover the inverter station due to the AC fault. Suppose on the HVDC link, if you are removing the load means dynamic voltage will be passes through the converter. You can able to protect the system such a way that the converter can able to withstand that high voltage due to the throwing of the load. These are the different parameters in which these are the different parameters which are improved nowadays. We can use the HVDC system practically also.